You're just telling us not. You don't care about level being horizontal. That's not an issue. But we are definitely on a curved Earth. Like level is curved. You're saying, right?
Yes, it is.
Right, there you go. So you don't care about one, but you do care about the other. That's
No,
what you're
I'm saying I'm saying we're not going over that scenario right now. We're going over the scenario of a curved Earth and the fact that level is following the curved Earth. The surface of water is curved on the curved Earth. That's the scenario we're going with. That's what you have to understand in order so we can get through to show you the errors you're making and why your conclusions are wrong and why the method you're using is not going to detect the Earth curvature because you don't have enough resolution in your auto level and your range poles to detect the Earth curvature in the double rod differential leveling scheme. It's impossible with the equipment you're using to detect the curved Earth. Curved level surface on the Earth. This is the surface of water. Okay? Now, we have our auto level sitting there and we're shooting a horizontal line out. So, on the curved Earth, everything looks like it's falling away from the auto level. That is the consequence of being on a curved Earth.
I got your numbers right here.
Horizontal.
It's just as easy.
Oh, shut up.
1, 2, 3. You have to open your mind.
True horizontal.
Imagination is all you need.
Oh, shut up.
Don't take advice from
To understand how the curved Earth
everything
works.
that they say is in vain. Never take advice from fools.
Oh, shut up.
We all know what they do is in vain.
Level and horizontal are the same thing. That's immaterial. We're talking about a curved Earth here. If you take a sphere and cut it with a plane, you get a circle, which represents the surface of a sphere.
And we're assuming that the auto level makes a horizontal, right?
Yes, at its position and setup, yes.
Everything is relative to you.
We're not measuring an angle.
You just have to say it in generalities.
Oh, shut up.
Just like those straight lines are curving.
1.330.
Drive down the road, don't you ever swerve. And I don't know
Yep, we've been at this a half an hour.
where all of this goes.
I'm going to give you 15 minutes. After that, I'm out of
Never
here.
take advice from fools.
I'm out of here.
Everything that they say is in vain.
Oh, shut up.
Never take advice from fools. Everything that they do is in vain.
You take a section of a sphere, you cut it with a plane, you get a circle. That gives you the outline of the profile of the surface of the sphere. It's a circle, and that's what you work with. And it's like, it's just a cross section, and that's Euclidean geometry. Oh, shut up!
I know the game that you're playing,
Never mind, Beth.
and I know exactly what's on your mind.
This
You
is
got your playbook, it's alright.
not going to go anywhere. I can see that because
Your model dictates what you will find.
you just don't understand the equipment and
I
what.
don't know
Oh, shut up!
where all of this goes. Don't take advice from fools.
Oh, shut up!
Everything that they say is in vain. Never take advice from fools. We all know what they do is in
Where the issue comes in is what are your limitations if you're trying to do this on a curved surface. That's where the problems come in. When you do a double peg test, the curve of the Earth is taken out because you're shooting equidistance on the foresight and backsight onto your two pegs. So those two marks that you put on your pegs are guaranteed to be at the same elevation.
Buster, are you there?
Yes, sir.
You're gonna love this, bro, and everybody else. I was going through the LIGO videos the other day. I just wanted to make sure where the motors were and this and that. I just wanted to make sure. So I forgot. How could I run into something and I go, how the hell did I forget this? We all know they're building an underground LIGO named Einstein. I think they named it Einstein, whatever. And the space one, right? We discussed that before.
Yeah, I remember that a little bit. Yeah.
Well, how did I forget this? They're going to build because they want to increase the sensitivity of the detection. So they want to build another LIGO with arms not 4 kilometers, but 40 kilometers long.
Did they say where?
No, they haven't chosen a site yet. No,
Gotcha.
as far as I can remember.
I bet they know where they want it to go.
Yeah. Now you guys can imagine the implications of that, right? A 40-kilometer arm that has to be perfectly straight and level.
Yep. A long way.
I can't
Upside
wait.
down they gotta go.
Yeah. I can't wait, bro, for this one.
Yeah.
Okay, I'm here. False alarm, I guess. I heard the igniter go on, but I didn't hear the natural gas ignite.
Okay, George. So,
Hello, George.
yeah, good morning.
Hey there, Bev.
I heard you were up late last night doing some research on.
No, I wasn't up late. Not real late, no.
Oh, okay. But you were, like when you got double rodding. I mean, they might call it something different.
When I got what?
When you went researching, looking for the double rodding.
No, I didn't do any research. I just worked out the geometry.
Oh, right. You just had to think about it, right? You
Yeah,
understood.
yeah.
Okay. All right.
Yeah, I mean, I've been aware of the double rod differential leveling, but I just looked at it always before, rather just really quick with the geometry and was satisfied with it. But this time I just sat down and looked at it in real detail, worked out the geometry to see what was going on in terms of angles and how the rods would read from various positions. And so I went into a lot of detail on it now, so I have a real good understanding of what's going on there geometrically.
Yeah, right. One thing at the beginning, when you say you worked out the geometry, do you mean you worked out whether it was Euclidean or non-Euclidean geometry? Wait, what type of geometry? Or did you just mean...
Well, of course, it's Euclidean geometry. Okay. It's plain geometry on a piece of paper.
Okay, so when we refer to geometry, we're talking about Euclidean geometry.
Yeah, of course.
Okay, and only Euclidean geometry, right? You'll let us know if you ever decide to want to swap geometries.
This isn't real complicated.
I know. It's pretty simple as far as I can see.
You don't need to know much more beyond the fact of intersecting lines. Line intersecting two parallels give you equal vertical angles and equal opposite angles, vertical angles, these sorts of things, adjacent angles, transverse angles, how they all are related to one another when you have parallels that are intersected by a line, the same line. And then the other thing is knowing how to compute arc lengths given a radius and an angle of sweep. What is the arc length? And that's about all you need to know, and maybe how a tangent function is defined, but that's the extent of the mathematics. The rest is just working algebra and the relationships of the angles and distances.
Yeah. All geometry would be deemed Euclidean, and all
Yes,
Euclidean
Beth.
principles.
Yes,
Okay, George.
yes.
I'm not. I'm not. I'm just. It's for everybody
This
else.
is just, yeah, this is just, okay. This is just basically no more than high school geometry. You know, they don't get beyond Euclidean geometry, plane geometry, plane, Plane, plane geometry. Not
Yeah.
solid geometry, not analytic geometry, but plane geometry.
That's good. So that's how you've worked this out.
Yes.
Okay. So what you mean is you've worked the numbers for how
Yes.
double rodding differential leveling works.
Yes.
Okay, brilliant.
Because you have to look at it in both, you know, in two cases. Is one is the simplest cases are over on a flat plane, a flat Earth, as you say.
A plane.
That makes it real simple.
Yeah, yeah.
And then the other one is you have to work it out on a curved Earth and see what the differences are.
That's not Euclidean then at that point, right?
Of course it is.
No, you can't bend the horizontal and say it's still Euclidean.
I didn't say I bent the horizontal.
Okay.
Bent the curve. Euclidean geometry, arcs are permitted in Euclidean geometry. You realize the simplest geometry is what the Greeks did, where they have a straight edge.
Yes, we know.
Beth, this is not going to work if you're going to interrupt me. I do not interrupt. I haven't been interrupting you.
Well, don't talk to me as though you're acting as though I'm stupid. I'm just telling you. I know book 3 in Euclid is the book about circles, right? They understand the geometry involved in this.
Okay, then why are you asking?
Because you're talking about a curved Earth as though it's Euclidean.
Looking at a cross section. If you take a sphere,
that's fine.
If you take a sphere and cut it with a plane, you get a circle, which represents the surface of a sphere. That is Euclidean.
Yes. Yeah. So not view. Spherical geometry, right?
No,
okay.
No,
right,
not whatsoever.
That's fine as long as we're understanding that at the beginning.
Yeah, I mean, you take a section of a sphere, you cut it with a plane, you get a circle. That gives you the outline of the profile of the surface of the sphere. It's a circle, and that's what you work with. And it's like, you know, it's just a cross section, and that's Euclidean geometry.
Okay, I get that. Now, do you want me to wipe my board and then we can get on the board and you can walk us through it if you haven't got any drawings?
Well, if you want to do that, but let's just talk about it first.
Okay. If we get struggling, then I can access the board for you if you want, right?
Yeah, that's fine.
Good.
Well, you were asking me yesterday about the readings on poles. If, say, you step the poles 75 meters apart, and then after setting your 2 first poles on the foresight on the differential leveling, and then moved your auto level ahead 75 meters, and then shot back on the backside to the poles, and you read, say, 1.330 on the first backside pole, what would I read on the other pole that's 150 meters away? And I gave you a number then, but I had only figured it using on the curved Earth. On the backside, I didn't figure in, as I told you, on the when setting up the 2 double rods, and it turns out it does modify the reading, and in fact, it makes it even harder to detect, because in the nature of the double rod differential leveling, it takes out most of the effects of the Earth curve. However, not all of it. There is a bit of residual left, and depending upon how far you space your poles from one another, and the auto level determines how much error you're going to get in your readings. And I was really quite surprised at 75 meters that if you're looking back after you move your auto level forward to do a back sight to the two double rods, and if you're reading 1.330, you actually have to have rods with much finer graduations and a auto level with much more capability in terms of resolution in order to read the errors that would be caused by earth curve, because it turns out when you're shooting back on your back sight at 150 meters to the first rod in the double rod, the error that you're only going to pick up is 1.3 millimeters. And that that works out less to, you're not going to be able to read that on your poles over 150 meters, because as you know, in rods that are read in metric, they're generally graduated in about 5 millimeter graduations, right? Bev?
I've got one that's got 5 mil, but they're usually centimeters.
Yes, a half a centimeter,
But-
5 millimeter, half a centimeter. Half a centimeter is
They do have ones that you can use to 0.02 of a millimeter. The precise ones, but
0.02 millimeters?
Yeah.
No way.
What?
No.
yeah, they get a micrometer
No.
on them.
A micrometer to get you to 0.02 millimeter.
Yeah.
But you can't read that. You can't read that at 150 meters. I
No,
mean,
50
maybe for
50
close-in work.
Yeah, 50 meters.
Yeah. Okay. Yeah, I'm talking at about 100 at the 150 meters, where you're going to have to sight back to the first rate, your first pole. The best you're going to be able to do at 1 arc second. Let's see here.
Well, what is it? 50 meters. What's the?
Just a minute. Okay, at 50 meters. Let's see.
Because all we're talking about here is the principles of the idea, right? Like if you can,
Yes,
you can,
but we also have to be concerned with how accurately we can read our poles.
yeah, but if you can make a straight line, then you can extend the straight line. That's the principles of the surveying,
Yes,
isn't it?
yes, yes, yes. Hang on a second. I gotta let Con out. Hang on, I'll be right back. He's having a little difficulty today with his food. Okay, sorry, I'm back. Okay, where were we?
I don't know. You were doing something. It was on you. You were explaining.
No, you had
to us
asked
this
me
method.
something. Well, you're asking me something about 50 meters. What resolution at 50 meters or something? We were talking about reading range poles.
Yeah, we're talking about there are auto levels out there that can read 0.02 of a millimeter with a micrometer.
But I'm not talking about what is out there. What I'm talking about is what you are using in doing your experiment. That's what we're limited to, not what can actually be done with the best
We're doing
equipment.
a concept here now, aren't we? You're going to explain to us
Okay,
this.
let's
this
assume.
method.
Okay, all right, fine. Let's assume we have a perfect auto level and perfect range poles. Okay.
Okay.
There's no limit to the resolution in our auto level. We can measure it down to the diameter of an atom, let's say.
Well,
Okay?
let's just say that there's no need for us to put a distance on here, because all we're talking about is the geometric principles of what's going on, right? So the number can be n, right? The distance between the poles, as long as it's the same, then we know what we're talking about, right? But if you want to give us some numbers from your
Okay.
model, you can give
Well,
us
I'll go
a
with the
number.
numbers. Yeah, I'll go with the numbers you gave me yesterday. We'll go with 75 meters, and we can also go with 33 meters.
We'll go
Okay.
with 75 and 150 then, right?
Yeah.
With the understanding that it could be any number.
Yes.
All we're doing
yes.
is the principle.
Yes.
of the
I have it figured out generally for any distance you want. Okay, I just didn't use a set number. I figured out the geometry in general, so we can put any distance you want in, and I can tell you what the errors are. All right, so now there's absolutely no issue when we're talking about doing this double rod differential leveling, say on a flat plane, a flat surface, because everything works out. I don't have any disagreement that everything lines along a straight line and are also parallels to horizontals. That's not the issue here, because that always works out on a flat surface. Where the issue comes in is what are your limitations if you're trying to do this on a curved surface. That's where the problems come in. And so if you take your double rods, just for the benefit of everyone, what you proposed yesterday is we start out with a rod that has a 1 meter height on it. The one thing we have to establish, though, is when we're setting up our rods and we're setting up our auto levels, we're assuming it's like on the surface of water, correct? That's perfectly smooth. There's no hills, there's no valleys where we have to make height or elevation corrections. We're just assuming it's a nice smooth surface like on a canal or a body of water, correct?
Yeah, we're assuming, assuming a level surface, right? Perfectly level surface on the floor.
Yeah, I call it a smooth surface.
And we're assuming that the auto level makes a horizontal, right?
Yes, at its position of setup, yes.
Okay.
So we're on a smooth surface, like on a canal, the surface of water, all right, still water. Nice smooth surface. Okay, so we start out, so the bottoms of all our poles are on this smooth surface. So you start out, you put a pole up, and you put a 1 meter mark above the surface. That's what you started with, and then you moved your auto level ahead, I don't know what, 5-10 meters or so to sight that to adjust the auto level to that height, right?
Yeah. Can you see that there?
Oh, are you presenting or something?
I have
okay.
I've got my camera on, so on the
Okay,
left
hold
hand
on.
side there.
Hold on.
I'm just going to keep updating it as we go.
Just a minute. Is there a way to expand this? It's just a thumbnail on my screen.
I think you double click it.
Oh, okay. Hang on. What the hell? My stream. What is going on here? I'm clicking it, but it doesn't. It just tells me about you. It's not giving me any options for the screen. This is different than what I've seen before. Huh. Hang on. I killed it. Huh. This is really weird.
How's it for everyone else?
Live or something? Don't you have to go live or something? All I'm getting is a thumbnail.
Is everyone else okay with the camera? Like, can you expand that?
Yeah, I got the screen on.
Yeah.
I can see it.
Yeah, you can.
Are you getting
expand
Are you getting full screen though, Montreal?
Yeah, I got full screen, George.
Give us a Discord lesson on how to enlarge the camera screen, please.
Well, all I'm getting is a thumbnail, and I'm not getting any options for expansion. There's nothing to grab
George, if you're using a phone, all you got to do is double tap.
I'm not using a phone. This is a computer, laptop.
Oh,
Go.
it should show up for you.
If you click on, see where we're talking here, George. Click on the
Yes,
live.
I've done that, Bev. I've done that.
Click
Yes.
on the live on YouTube, so you see everybody's individual bits. There should be a
Yes,
page.
I'm there.
Right
Yes.
now, double click on the one that you want to watch.
Hold on. I got it here. Okay. Something's changed on my Discord. Okay. All right. So you got your 1 meter height. All right.
Yeah.
You got your auto level set up.
Here, and we set it, and we're measuring 1 meter on this first click, right? We've got
Correct.
75 meters, and then over the 2, 150. 75, 150. This is the back side. This is the foresight. That's all we're really bothered about, right?
But almost. I mean, yesterday what you wanted to do was when you moved your auto level head, you raised it up so that it was shooting that second pole on the foresight. Well, why don't you label the poles so we know what we're talking about? Call the first pole pole A, the second pole pole B.
You want to name the poles?
Yeah, because it makes it much easier to talk about what we're talking about. Yeah, that's A, that's B. Now call the first position of the auto level 1 and the second position 2.
Well, we'll call this one, okay.
Just call it 1, position 1, position 2. All right, that makes it much easier. All right. So the auto level at 1 to site pole A is 75 meters, pole A to pole B is 75 meters, and then we move the auto level ahead so that pole B is 75 meters from that auto level. But yesterday you were raising the auto level so that when you did the back sight to B, rather than sighting the mark that you did on the foresight, you were actually above 1 meter. You're at 1.33 meters. Do you still want to do that, or how do you want to do this?
Well, that's what you would do, right? You would. I mean, it's up to you. I mean, you're the one that's had to think about this. So you tell us your way. I was just trying to give you a practical idea of.
Let's just do the practical idea. Let's just go with that. Okay. Let's go with the numbers you used yesterday. So the auto level at position 2 has been raised up, so when you're sighting, doing your back sight to B, rather than reading 1 meter, you're reading 1.330 meters, okay?
Okay. Are you not going to sight the second one from point 1 before moving it yet, though?
No, I'm assuming you already did that.
This is you, George.
Well, I said.
You've done
okay.
You've done the maths right.
We'll go through it a step at a time. I'm just trying to jump us ahead here.
Okay. Right.
To where we were yesterday. All right.
Let's do it right from the beginning. Right from the very start. Right. So
okay.
What we've done is we've got the auto level. We've set it up. We've done our 2 peg test. It's all working fine. And we've got it. We've put it here, and we are looking at the datum, and it's 1 meter. Right, so the height of this auto level above the datum, initial datum, is 1 meter. Right?
Yeah.
Then we're turning the auto level and we're looking this way.
Now, Val, wait. Do you have any colored pens, like a red?
Got a green. They're
well,
all
I mean
blue.
something to get a different color. Do you have something like a red? You have some red writing on the right there. Do you have that pen handy so we can make some marks to differentiate from the green?
What for? You just want a different colored pen?
Well, it will make it easier in my explanation.
In your explanation. Right, I've got a red pen here. But
all right.
That one's no good. Let's see that one. Go on. Don't huff and puff at me, George. Go on.
Oh, God.
Right, so we've measured this at 1 meter. Yeah?
Yes.
Okay. Off you go. Carry on. I'll just
Um,
adjustments to this as you're telling us. What
Is there some way to focus this better? I mean, the image
just
is
carry
very
on
poor.
explaining, George, and
I'm saying the
I'll update
image.
this.
The image is very poor. Is there
Yeah,
some way to do a better focus?
Don't let me lead you, George. Off you go. Have you got some glasses?
Oh, fuck you. Goodbye.
Anytime you're ready, George.
I mean, the image looks good for me.
Oh, what's going on there, Turner? Whoa, that's...
But
Wow, bad robot.
am I
Yeah,
right?
yeah, that's not good. You need to leave and come back again. I thought we were going to get... I'm stood up here now, George. Do I have to... I got my red pen out.
Look, Bev, I'm not really interested in having this discussion with you anymore. Like I said, is if all you're going to do is try to make fun of the fact that you have shitty video and blaming it on me, there's just nowhere to go on this. You're just an asshole. You behave like an asshole.
There. You carry on. Tell us.
No, you behave like an asshole, and I'm not interested.
George.
We're not going to have a productive discussion because you just
George,
can't.
you just made a joke about your glasses. Come on, man. What's wrong with you?
You don't need to see this. This isn't for you.
Yes,
I'm
I
trying to
do.
explain.
Yes, I do. So I know that you are understanding what I'm telling you.
Okay. Well, everyone else can see it. Can everyone else see it?
Yes.
There you go. Right. So we've done our back sight, George, and we know the height of the auto level. 1 meter. Where do we go from here?
Well, what would work better is you have some black writing above your poles. I want you to extend your poles upward a little bit and move your auto level in position 2 upward, because your auto level from yesterday was in position 2 is higher than the auto level in position 1. So if we're going to go through the scenario you presented yesterday, we have to have an accurate diagram.
Well, let's start off with the auto level in position 1, and let's deal with that first, and I'll do the adjustments for everything else later.
No, we do it as we go, and we take care of it on the run. Otherwise,
we've only got one auto level, George, and it's at the first position right now. We've just measured
okay.
1
What
meter.
I want you to do is wipe your board clean, and we'll start over.
George, no!
No,
Come
you
on!
wipe it clean, then we're not going to do this.
All right, don't then.
All right.
You
Goodbye.
carry on with your explanation of what's going on, and I'm going to do my best to represent it, like I have been doing all along.
You can't do it with the way you have it written, because the auto level in position 2,
I'm
we're
just
going
going
to
to
raise
write numbers on it, aren't I, George?
God.
Isn't that what I'm doing?
Why is this so difficult for you?
Right, look, everybody that's looking in here now, right? We've got an auto level. We've set it up here. We're going to look at this rod and this rod. This one's 75 meters away. This one's 75 meters away. Once we've done that, we are going to take this and move it to here, which is 75 meters away from this one, and 150 meters away from this one. So they're there. Then we're going to read the numbers on there and there. Now, does the location of where this is matter to anybody? Anybody else?
The height of it matters.
Do you understand what's going on here?
Yes.
Okay. Come on, George. Walk us through it.
Okay, so in position 2 now, you're doing a back sight from position 2.
From here, this way, yeah.
Yes, all right. The reading that you proposed to me yesterday, that you're reading on pole B, is 1.330 meters.
Oh, it was on both of them, actually.
Huh?
You want me to mark that on there now, do you?
Yes.
Okay. So, this one from this side, 1.33 meters. There you go.
Okay. Now you're going to cite pole A from that same position too. Yes, and you asked me what would be the reading on position pole A.
Yeah.
And the reading there, if we're on level water on a curved earth, that reading will not be 1.33 meters, but will be 1.33013 meters, slightly higher than what you read on pole B. You don't have enough resolution there.
Right, well, come on, what did you say? 1.
Okay, let's put it in terms of millimeters.
1.33.
013.
013 meters.
That's the actual reading that you'd have. If you have a very good odd level and a very good range pole, that's what you should be reading. So, when you connect those 2 points with a straight line, that line is not going to be horizontal. It's going to be slightly tilted because the reading on pole A is slightly higher than the reading on pole B.
The line across there from here won't be horizontal, you say?
Yeah, well, obviously it won't be because it's slightly higher.
Okay, because the numbers are different, right?
That's right.
Okay. So, over this distance here, right, well, let's do this one, because this is you can't, these numbers here are meaningless until we've got this one, because we've started here.
That's correct, okay, we'll do that one.
Right, so
Yes.
we started off at a meter. What's this first reading?
That first reading will be 1.00044.
1.0
00044.
meters.
It's 0.44 millimeters high.
Okay. 0.44 millimeters.
Yes.
Okay.
Almost a half a millimeter high over the 75 meters.
And what about...
And then on pole B, the reading will be high by 1.3 millimeters, or you'll be reading 1.33013. 013. 013.
What, from the first one? Looking at
That's
B?
right. That's right. So that's going to be reading even a little bit higher.
You sure that's right? That doesn't look right, that, Judge.
Well, it might not look right. It's because when you join the lines, you'll find they're not parallel.
Right, well...
See, you're assuming they're parallel. If you truncate everything to 1.33, it looks like they're parallel. But in actuality, you have to use much finer resolution to find out what the differences are.
Right.
You have to go out to more decimal places.
Can I speak?
Yeah.
Right, so the first reading, according to you, is half a millimeter high at the first reading at 75 meters. So
correct.
Over here, from this first 75, it's gone down, right? The ground has dropped, which gives us a bigger reading, right?
Correct.
Okay. Now, the ground has dropped nearly 0.5 of a millimeter over the 75
correct.
meters. And at
correct.
the second pole, yeah, you've got a reading of 1.33013.
Correct. So the pole is dropped 1.3 millimeters.
No, it's dropped
1.3 millimeters.
33 centimeters, right?
No, 1.3 millimeters.
1.33013.
That's right, 1.33013.
Right, well that's...
1.33013.
Yeah.
I can't read your board.
But you.
The focus is bad.
Yeah, but you're giving me these numbers, right? It's gone from 1.00044.
What number is that? Right in the second one. What's the number you wrote down?
1.33013.
Yes, that's 1.3 millimeters high.
But you did that from here, right? You got. You're getting yourself confused, George. Why
No, you're confused.
From the first
Bev, the green numbers are on the back sight or on the foresight from position 1.
Yes.
We've got, okay, please listen, so you have the numbers right.
You see the numbers? Okay, go on, give us the numbers again. Number on
okay,
pole
the
A.
first one, pole A is 1.0. Why don't you put it in all in millimeters? Then it's easier. Oh, well, hell with it. Okay, it's 1.3300.
George.
We're doing it in meters. I said 1.330044.
George.
Oh, fuck you. Aren't you listening?
For 1 meter, right?
Yes, I'm giving it to you in meters. Right. Listen up.
You want me to change this number here? This is this first pole number, right?
That's right. Pole A.
Pole A with the first one from the beginning, from the datum.
Is 1
meter.
The first one is 1 meter exactly.
Yeah, the datum.
The datum is 1 meter. 1.00000000000 meters.
That's the height of the auto level.
Oh, fuck.
Right?
Yes.
Okay. Now we're on to the first pole. What number would we read on the pole?
The number you will read on the first pole, pole A, is 1.0 or 1.33044 meters.
You've got a broken auto level at the first one there, George.
No, you don't. That's because of the earth curve. The pole has dropped a little bit.
But not 33 centimeters, George. Surely not.
It hasn't dropped 30. Oh, I'm sorry. Okay, God. You got me screwed up. All right.
No, you've got yourself screwed up.
All right. Forget. Forget.
George, please calm down.
Okay. All right, Bab. I'm having a hard time seeing what you're doing on the board here. It's so fuzzy.
Don't read off my board. Read off your numbers.
Okay, all right. Wipe the numbers out. Clear them off. Leave the red ones. Just do the green ones there. Okay. All right. Pardon me. Yeah.
That wasn't me, was it, George?
No, I apologize. It was me. I was having a hard time reading what you're doing on the board. I don't know why your video is so poor, but anyway. Okay, pole A.
Cheap cameras.
From the auto level at position 1, you're going to read on pole A 1.00044. Okay? And on the second pole, you're going to read 1.00176. Okay?
Okay.
All right. Now, when we move our auto level forward to position 2 and do our backside, the numbers we're going to read, the first pole, you set it up to read 1.33000 exactly. You're adjusting it so it reads that number.
No, we just set it up, and that's the number we read.
That's right. That's what I just said. That's the number you've set it up to read. So on the second...
No, George. When we set it up...
I just said that, Bab. You've set it up, and you're shooting the pole, and that's the number you're reading on the pole.
Yes.
Yes.
Yeah, we didn't
1.33...
We just set
1.33 exactly. That's what you're reading on the pole.
Okay.
From your setup. Now, the question is what are we going to read on pole A? On pole A, we are going to read 1.33044. 0, 1, 3, 2.
1, 3, 2.
Okay.
The 2 in. You got
So those are the numbers.
better.
And that's due to earth curve.
Right, okay. So the difference between here to here is 0, 0, 0, 1, 3, 2. Yeah? And the difference from here to here is 0, 0, 0, 1, 3, 2. Again, that's good. Almost as if you've calculated it. So we've got, now, because these are horizontals and this is it dropping, right? This line here, the land is dropping in between from this one, right?
Correct.
And from this one, when we're looking this way, it's dropping also.
That's correct.
Right, so it's dropping from both sides.
Correct.
Okay. Now, when we draw those lines in for the horizontals, would this one be like at that angle and this one be at this angle? In order to get these numbers? Or is that the floor? The floor would be dropping down, right?
Well, you got to connect the greens with the greens and the reds with the reds.
Yeah, but obviously, because this is a horizontal and we're measuring the drop of the land, right, then it's the land that's dropping away at the underneath, isn't it? Like, we could do this. We could do that. And put the horizontal would be horizontal all the way across. And then from the green side, we've got the land going down like that. And then from the red side, we've got the land going down like that.
Well, what you will find, Bev, if you will find,
right?
Given your laser light there, say that's your horizontal. That's the horizontal established by the auto level at position 1. Now, if you were to connect the points that I gave you for A and B pole, you'll find that the green ones, the line defined by the green will be
it's horizontal.
Horizontal.
It's the land.
That's horizontal.
Because that's what we're measuring. We're measuring the distance of the land
That's right.
from this from this line down.
That's right. That's a horizontal.
Yeah,
yes.
So
and
the
the difference that you're
one
finding,
way, and then the land drops the other way.
Bev, please. Oh, God.
Yeah.
Bev, please.
Yeah.
The difference in the numbers is the fact that the bottoms of the poles have dropped a little bit. The tops are lined up with the horizontal, but the bottoms are not, okay? Because of the earth curvature falling away.
Yeah.
Okay, you agree with that. All right. So where the problem comes in now is when you've moved
both sides. That's the problem. There, can you not see that? It's dropping. This one's dropping that way, and then when you're here, it's dropping this way. It's like which way is it dropping? The land.
It goes both ways. It just depends on where you set up.
The land drops both ways. I mean, it's the
It's
land
not.
that you're measuring.
It's dropping with respect to the horizontal. It's not in actuality dropping. It's how you measure it with respect to the horizontal.
No,
the fact
land,
that the earth curves away from the horizontal.
The land is definitely dropping. If you're measuring a larger number here than you are here, it's dropping the land. That's
yes, it is.
Yeah.
From the perspective of the auto level at 1, the land is dropping away, and also from the perspective of auto level at position 2, it is also dropping.
But it can't actually be dropping both ways.
Yes, it is. Yes, it. Well, it's not dropping as in elevation. The elevation is staying the same. It's we're on a curved surface.
What? How do you make these two slopes into a curve? Like, what's that about? I don't understand, George.
I know you don't understand. That's been the whole problem.
Well, I don't know. Like,
well, tell you what, take a break. Take a break. Now, take a break. I'll do a little diagram for you. Maybe it can clear it up. Okay. Give me about 10 minutes here. I'll make you a little diagram. I'll be back.
Let's have a chat with the guys then. Right, guys. any problems with that? I mean, because that does seem to me like that's dropping. If you're getting a larger number further away than there, the land has to be dropping, right? I mean, if the horizontal is at an angle, then it's not really horizontal, is it? Like,
No.
Well, George just said we can have a drop. He agreed to that, but then he said,
Did you cut out, I see?
I think so.
that's quite remarkable, wouldn't you say? Unless I understood him wrong.
I think you might have cut out there, Essie.
I said, unless I understood him wrong.
Yeah, I think the bit before that you cut out.
Oh, sorry. If I heard him correctly, I think he said we can have drop without elevation change.
Yeah, I think so. I think he's trying to justify these numbers and way that these two slopes go.
No, Montreal, that's not what I said. I said without elevation change, there's drop relative to a horizontal that might be tangent or parallel to a tangent to the earth. I'll show you that in a second, but no, that's not what I said.
Okay, sorry, George, I stand corrected.
Where do the numbers come from?
He's calculated them, obviously.
Right, okay.
That's what he spent last night doing some sums.
And these are verified, or just numbers from calculator?
No, dude, it's 0.5 millimetre.
Oh, true, yeah.
Nobody would
0.5
ever measure 0.5 millimetre.
mil. Yeah.
I've missed some of this. Can anyone just fill me in what's going on with that?
Can you see the picture? Spot on.
Yeah, it's gone there, yeah.
So we start off, we've got an auto level, right? We're doing, George is running us through the differential double rodding, right? So,
Yeah.
So we set up an auto level at point 1. We take our datum from here, and it turns out auto level 1 meter.
Yeah.
Then we go 75 meters. He didn't ask us how far away we were from the datum. But, I mean, let's assume that we're right on it. Let's assume for some stupid reason we set the datum and we set the auto level right on top of the datum. And then we're sighting 75 meters away is our first pole.
Yeah.
And we're measuring 1.00044 meters, which is half of a mil, or not even half a millimeter. Right?
Right.
And then we go to 150 meters, second pole, same station, and we measure 1.00176 meters, which is 1.8 millimeters.
So it's slowly getting lower, yeah? The further you get away.
Yeah. The land is dropping, or because you're reading a higher number on the rod.
Yeah.
Right.
That's that.
So what you do is then you get you do your transition, you move your auto level to 0.2, and you now take backsides on these 2 pins. The first pin reads 1.33 meters.
1 point what?
1.33.
Yeah.
And then the second pole, it then reads 1.330132 meters, which is 1.32 millimeters different, right? Which is the same.
Oh, what? Okay, so
it's dropping this way as well.
what's actually establishing here? Are you in the ground then? You're trying to.
What we've got is that the land is dropping from 1 down.
Yeah.
And then when you move your auto level to 2, you've also got a downwards drop, which counteracts the one that we've done there. You would say at that point there's something wrong here.
Yeah.
My auto level's out. I would anyway. If I did that,
Yeah.
it can't be dropping in both directions. There's something wrong, I would say.
Well, no,
George
but
is, George
exactly.
is now doing us a new picture to explain it because this
Oh, is he?
doesn't seem to have explained it right.
Can't see how you're going to explain that. I mean,
Well, other than
if
not
you look
putting
back,
the
then the other
horizontal,
measurement
he's
will
gonna
be higher.
Yeah, he's going to have to tilt the horizontal in order to make this level. It's the only thing he can do,
Yeah.
but it's not going to make any sense. Again.
Well, no.
Come on,
I mean,
guys, it's simple.
especially over that distance. I mean, 75 meters, easily measurable. Like, it's just not a problem. I mean, it's just bang on, 0, done.
Yeah. Right, well, the next one is, as you can see, I've put these posts here. Because, obviously, if we're going to do something on here, a bit iffy, on this side, in order to debunk this, then it's going to have the opposite effect down here, right? If this is tilting, in order to bring that up, then it's going to be sloping down on this side. It has to be horizontal all the way across, right? What happens here...
You're not thinking clearly,
happen
Dev.
here.
You're not thinking clearly. I'd say it's a double drop.
Well,
The way George explained
I
it.
think this drop here that he has coming from this one will also happen over here as well.
Yeah. Oh, yeah.
But we'll have to wait for George. I think he's calculating. It's a calculating nightmare, this thing.
Well, I don't know how he's going to sort of, considering that, you know, like, there's no reason why. Well, unless you've got, like, unless the Earth is moving at, like, a change of elevation from point A where you set it up and dropping away, it's a very small amount, like, literally. What is the, so it's 1.33, no, sorry, it's not. What was the second point at 150 meters? Lower than the actual...
Yeah, it's 1.32 millimeters.
1.32
millimeters lower. Yeah, the land, because we've had a level surface, right? That was one of the requirements at the beginning, right? The auto level sets a horizontal, and the land underneath is level. That's what we said.
So why has he got a different measurement than the other?
Yeah.
Is that not 0?
Yeah, it's going down.
Or 1 meter?
Going down.
He's got 2 drops there going on.
Yeah.
Yeah, I mean, like, he's obviously never done any surveying. That's what that...
Yeah, he's calculated it. He spent last night calculating it.
Maybe we misunderstood the... we got to wait for his diagram. Maybe we got it all wrong here.
If you've got a level floor, if you've got a level ground, and you put the staff on it, any position, then it'll be 0, right? Can't be any other. And then if you move your thing and you're measuring the same thing again, but from a different position, it'll still be 0.
Yeah, whatever the datum is, if this land's level and you've set this tool up correctly, you've checked it with a 2-peg test, then every reading you take should be 1 meter. Because that's the height of this, and this is the ground's level.
For the auto position 1, it's been actually measured to the height of 1 meter, so you don't need to measure the height the other on position 2. You just sight back.
Well, this is where you get your datum from here. Like, that's your first point, right? So the first point is the height that you're starting at. And then you just add the height of your auto level to that datum. And then that becomes your new, like, this becomes your new datum then.
Yeah.
And then you just read the height here. And well, if this surface is level, you should get 1 meter, 1 meter, and then move it over here. Whatever you cite here, you should also...
It might be 1100, it might be 1.1, and then the other one will be 1. And you turn 180 degrees to your next pole and mark it at 1.1 meters.
Yeah, 1.1, 1.1. Or 1.3, 1.3. You know, like, all of these, 1, 2, 3, 4, would be the same. Now, presuming they're not, because the land's up and down, the difference between them will always be the same when you make the transition. Right? It will show that these lines are parallel. even if the ground isn't, and that's how you can
Yeah,
tell.
but I thought you said the ground was level.
Yeah, that's what, like I was saying, like in this circumstance that we set up for George, yes. I'm just saying that if it wasn't level, be taking these readings, you'd be still be able to tell that you've set it up right. With both of these readings, if you got from here to here, you would definitely know, because you've got 2 posts, whether you've done a mistake. If you've only got 1 post, right, you're only ever going to know by the time you loop back and check your accuracy at the end. But
that's the purpose, isn't it, of the double rod,
The double rodding shows you it's
ultra exactly.
accurate.
Therefore, those first 2 measurements you got are different. That's the problem right there. You start there and go, right, you know, that's something's like, it's not 0.
The problem with it
wrong.
is that he has got different readings, but they're different in the opposite direction. I mean, these readings, these numbers here, show that your auto level is going the other way.
Yeah.
I've got my video's coming out, so I've got to do a bit of promotion on the video for a minute. So George has put a picture up.
Okay, Bev.
Okay.
You ready?
You all right, George?
Hi there, Mr. Australia. I assume you're in Australia.
Not the last time I checked. I have been there, but not right now.
All right. Hang on, Bev. I've got to turn the furnace off. I'm having a hard time hearing you guys with the blower on.
Right, I've got a premiere out if anyone can share these links out for us to the places that I can't get to. Especially Blues. I'm sure Blue would love to see this one.
You're meant to share it, Blue, or someone else can.
You're risking your position in his in his server.
Okay. Now, on this diagram, let's look at the top part first. Forget about the bottom at the moment. Because I have an auto level set up on the curved earth, and the auto level is shooting a horizontal line. Okay? That's the red line. No matter how I look from the auto level, the surface is curved away from me. It doesn't matter what direction I look. The auto level sees the earth curving away. That's what happens on the curved earth. So
what about if the land rises?
No, the land is... Oh, God. We're on a level surface. We're on the surface of water. Forget about land topography. Our scenario is we're on level surface, smooth surface
so
of
you're
water.
assuming that the surface floats away, right?
The surface floats away.
Yeah, well, you're saying level like means like something different to me than it does you.
Oh, Jesus Christ. What's wrong with you guys? We initially started. Okay.
Bricklayer. Yeah? Level is horizontal.
Oh, wonderful.
Right. Well, what are you trying to tell me? That it's not? I'm George, but like you're making it out like there's something wrong with us.
It's like horizontal there in your picture, George. Is that in the middle there? Is that horizontal?
We've been at this a half an hour. I'm going to give you 15 minutes. After that, I'm out of here. So if you guys are going to keep interrupting me,
I'll keep
quiet.
Yeah.
Sorry, man.
Okay. 15 minutes. If I don't get done in 15 minutes, I'll never get done.
Well, that'll do, because I've got a video on, George.
All right.
I've got a premiere.
Now, okay, on the top diagram, I'm showing you curved, level surface on the earth. This is the surface of water, okay? Now, we have our auto level sitting there, and we're shooting a horizontal line out. So, on the curved earth, everything looks like it's falling away from the auto level. That is the consequence of being on a curved earth. I don't care if you guys think we're on flat or a flat Earth and level and horizontal are the same thing. That's immaterial. We're talking about a curved Earth here, and for you to understand how the curved Earth works. Okay, if you're gonna fucking laugh, I'm out of here. Jesus Christ, Bev.
You're just telling us not you don't care about level being horizontal. That's not an issue. But we are definitely on a curved Earth. Like level is curved, you're saying, right?
Yes, it is.
Right, there you go. So you don't care about one, but you do care about the other. That's
No,
what you're
I'm saying I'm saying we're not going over that scenario right now. We're going over the scenario of a curved Earth and the fact that level is following the curved Earth. The surface of water is curved on the curved Earth. That's the scenario we're going with. That's what you have to understand in order so we can get through to show you the errors you're making and why your conclusions are wrong and why the method you're using is not going to detect the Earth curvature because you don't have enough resolution in your auto level and your range poles to detect the Earth curvature in the double rod differential leveling scheme. It's impossible with the equipment you're using to detect the curved Earth. That's what I'm getting at. That's where I'm leading to.
So what that method that you've just shown us there, then that shows that your auto level's knackered, right?
The auto level doesn't have enough resolution. It's accurate within its accuracy within the resolving power it has. You can't resolve any better than 1 arc second. In order to make these measurements at 75 meters, you're going to have an auto level that can resolve better than 1 arc second. Be able to set your crosshairs to better than 1 arc second. That's the issue we're faced with.
They don't do it. They do not do angles. It's an auto level job.
I told you, no, you're not doing angles, but when you're looking through your auto level and you in a sense are looking at angles when somebody is moving their range pole up and down, you're trying to get them to center the graduation or you're trying to read the graduation. How accurately can you read that graduation? You can move your eye a little bit or sight on the crosshair. The thickness of the crosshair is about 2 arc seconds thickness. That's what it blocks out in your image. And you have to be able to, oh, shut up. You have to be able to resolve or find that graduation within the crosshair. You have to center up the center of the graduation to the center of the crosshair. How good can you do that? Most people can't do it with a 1 arc second auto level to better than 1 arc second at best. And you have to be able to do it within tenths of an arc second. You don't have that capability with your equipment. That's why you're not seeing the Earth curvature, because it gets swamped out by the capability of your being able to center up your auto level with your range pole to make that accurate reading on your range pole.
It's just a simple double rodding process, though, George, right?
Yes, but you have to accurately be able to read your graduations, and you can't do it to the resolution or to the accuracy to which we need to go. We need to do it within millimeters out of 75 meters. You can't do it with your equipment.
Well, let's
That's
say,
why you are
George,
concluding everything's horizontal.
Let's say we've got a precision level, right? Let's say we've got a precision level. Right?
Well, then the numbers I gave you are accurate.
Then we are going to do, George, we are going to do a 2-peg test. You know how those work?
You know I know how that works.
Right, well,
come on,
what's the furthest distance we can get away from each other without noticing the curve of the Earth? Without mentioning the curve of the level underneath? Because surely you'd be thinking you're making mistakes. You think your level will be knackered all the time, really.
When you do a double peg test, the curve of the Earth is taken out because you're shooting equidistance on a foresight and backsight onto your 2 pegs. So those 2 marks that you put on your pegs are guaranteed to be at the same elevation.
Are you sure you know what a 2-peg test is, George?
Oh, fuck you. You know I do. I described it to you yesterday.
Well, then,
Now,
in that case,
quit
you
being
know, George.
Quit being so goddamn condescending. I'm really tired of this shit.
In that
Beth, the
case,
way
then,
you treat
George,
people.
you would know that you move the auto level to close to one of the posts, the two pegs. You move the auto level to one of the posts.
After you set up your first two marks at the same elevation,
and that's
then
why
move
you
your
check.
auto level.
You check. You're doing this method, the double rodding, in order to make sure your equipment is horizontal, George.
Yes, and when you're using the two-peg test in order to ensure that Earth curve is not affecting you, say with a 1 arcsecond auto level, you do your two-peg
Doesn't
test
measure
so that the
angles,
shut
George.
Up,
Stop saying it's an arcsecond. They don't measure
up,
angles, George.
I didn't say angles. Shut up. I didn't mention
What's an
angles.
arcsecond, George?
Oh, God.
What's an arcsecond, George?
That is the accuracy of which the compensator.
What is it,
the
George? What is an arcsecond?
Oh, fuck.
Is it an angle, George?
It's an angle. It's
That
the
the auto
angle.
level does not measure.
It's not a measurement of an angle in the auto level. What the arcsecond means in an auto level is how accurately the compensator sets itself with respect to horizontal. There's always some errors. It says that when you have a 1 arcsecond auto level, that the compensator is moving that crosshair in the reticule that you see in your eyepiece to within 1 arcsecond of true horizontal. That's what it means. We're not measuring an angle. It just says how accurately is that crosshair in the reticule deviating from true horizontal. It could be off as much as 1 arcsecond. That's what it means.
How would you know it's going to be off 1 arcsecond when you've got a device that doesn't measure
That's
angles?
the accuracy of the instrument, and you check it with a two-peg
Why is the
test.
accuracy of an instrument that doesn't measure angles measured in angle accuracy?
Ask the manufacturer. Don't ask me. Okay?
I've never heard of that. I've only ever heard you mention that, George. I know it's 1 millimeter over a 1 kilometer double run.
You didn't know. The other day, you didn't know how theodolites work. You didn't know anything about collimation.
That's
you
what you. That's what you
assume,
assume, George. That's what you assume.
You don't know shit about your equipment.
Right.
You have no idea how an auto level works.
You seem
I
to
know
be
that from
obfuscating
previous
in a minute,
discussions.
George.
No, you don't know anything about the equipment. You come on here acting like you're some goddamn.
You come on here. You came here, George.
Surveyor, and you don't know shit. You've never taken.
You came here, George.
Never mind, Bev. This is not going to go anywhere. I can see that because you just don't understand the equipment and what specifications
George,
mean
you're saying
on
he
this
doesn't
equipment.
Yeah, he's shown a certificate that he's
He
done
got some
surveying.
certificate from secondary school. That's not a surveying.
No, he's at college, mate. What are you on about?
He's just listened to the
surveying?
trolls. Don't worry about it.
Like, literally, why don't you ask? You ask Bev, like, where he got his certificate. I don't know. You can't just say that. He doesn't say that about what you know, does he? Like, what are your certificates? What have you got? And we'll just say that you haven't got them.
He hasn't got any surveying stuff. He's told us. I mean, none of them have
I'm a
you, George?
professional engineer. I have what's. Never mind.
Yeah.
Never mind. Jesus
No,
Christ.
none, George. It's okay. I mean, this is pretty
If you
simple.
want
This
to
is
know,
basic
Okay,
geometric
hang on.
principles, George.
Bev,
I want to back Bev up there with the. I've seen him use.
Bev, will you shut this
I've
guy
seen him
up?
do it.
I can't talk to you both at the same time. Will you shut this
know
on
you
the right
can't. I'm
line
just-
up? Shut him up. Okay, well, I'm going to set him to 0 so I can talk to you, Bev.
No, George, I'm going to set you to 0 because he's saying something. Can
I
you
don't
please
No,
let
I'm not
him,
listening to him
George?
anymore.
Can you
I'm not
please
gonna
let
listen.
him talk?
This discussion
George.
is going to be between you and me and no
George,
one else.
do
If
not
it
come
can't
in
be-
here and dictate this bullshit again.
Well,
We don't want Snowflake George here. George.
This conversation is either going to be between you or
All
I.
right, well, I'm not telling people who come in here all the time to stop talking because Snowflake George is here.
Good luck.
You're old enough now, George.
Especially he's saying that you've not, you've got no idea about the equipment. Especially, he said about the auto level he's got on it.
Yeah.
Bye, George.
Yeah, I mean,
it's fucking outrageous, isn't it?
Well, yeah, because he has to. That's the narrative he has to push. This is getting ridiculous at the time now. I mean, that was pretty obvious that he doesn't know anything about differential leveling. He's never done it. He doesn't understand the principles of it. He just showed us he didn't have a clue what a two-peg test was. Because if you move a two-peg, if you move your auto level to one side, according to him, the further one away drops, which would invalidate your two-peg test. They've never looked at this at all.
I mean, 75, 150 metres. You should be able to get that within that 1 millimetre. And, I can't see why you would ever have to add anything to either of those measurements. It is what it is. Awesome. As long as you've done a two-peg test, you all know this, but...
He's just got the land sloping in both directions. But thinking it's level.
But the land isn't sloping, though, is it?
No, but you see the picture he came back with?
Yeah.
Literally, he lifted the horizontals upwards.
Did George?
We used to get on quite well.
Actually, sorry.
I
was just asking if George actually revealed what tools would Earth curve be detectable with?
Well, we didn't get there because it got triggered. But I mean, yeah, we just get longer water levels and use this very principle.
I mean, he's saying that with differential leveling and the tools that you're using, Bev, you wouldn't detect it. So what tools would you be able to detect it with?
We did say he said you could detect it. Like he showed us there, 1 millimetre. If it's there to be measured, you can measure it, guaranteed. Like if there's a drop, then you can measure it. There's tools out there. George is not thinking about what surveyors do.
Yeah, I think he's a little insane.
Yeah.
Personally, because when we were trying to establish, when he had that one diagram where he's got the curve and he's got the different points along that curve, he was saying that you measure the height of the auto level or instrument, whatever, and then you make a mark at that height at the first pole. You go past that pole, backside it, and line up your tool to that mark. And then you go and you keep on doing that procedure, 7 whatever. And I said, so all you're doing is transferring the elevation of your instrument. You're not actually measuring the elevation of the ground underneath the instrument. He's like, no, I'm like, you just described how you would keep that same elevation off of the ground that your instrument is. You're not doing anything else. I don't know.
It's literally, you are using the tool to set a horizontal. You are using that horizontal as the reference frame, and making a note of where that is every time. Mathematical procedure.
I'm sure I heard George say when you do the two-peg test, you get the horizontal, but it doesn't work when you do the two-rod test.
Yeah.
So he contradicted himself.
Well, according to George, when you do the 2-peg test, you should see the drop because you are offsetting the level. Whereas when you do it like he assumes you do it and it cancels it out if they're equal. Well, this one puts a 75 versus a 150 on the other side. But George forgets that it's the height of the tool that you're using. That is the datum every time. It's the height of the tool in the middle that you're using. But yet you're referencing that height of the tool in the middle from your datum, however far away. It doesn't quite work. Oh, you guys. Look at George. He has no interest in talking to anybody else but me. Just me. George doesn't want to talk to you guys. None of you.
So sweet.
Just me. But this server's a piece of crap. Maybe we could get a little private server for me and George.
Sweet on you, Bev.
Yeah, I think you might want that. See if you
It
can
looks
set
like
a
F
Bev and George
F
server.
F you.
Bev and George in a Discord server. Hey, it could be good. You guys will never know what we're talking about.
George will be start growing a beard soon.
3 years. It doesn't have 3 years to get it through. You guys, you don't understand what's going on.
If you enjoyed the content, please support On the Level and future projects. Membership subscriptions available now, or come and get involved at Next Level Discord server. Thank you.